Welcome to Maths with EJD. In this video, I'll be starting out with coordinate geometry. Coordinate geometry. Of course, this first video will be about introduction to coordinate geometry. Right. So, as we consider this, let's look at a history. Let's look at the history and importance of coordinate geometry to start with. So, coordinate geometry, of course, also known as analytic geometry, is a branch of mathematics that uses algebraic methods to represent and solve geometric problems. Its foundation was laid by René Descartes, 1596 to 1650, a French mathematician and philosopher who introduced the idea of describing points in space using ordered pairs of numbers. So, when you talk about the x and y coordinates, his 1637 work, La Géométrie, revolutionized geometry by merging algebra with Euclidean geometry. So this innovation allowed geometric shapes to be expressed as equations, and conversely, equations to be visualized as geometric figures. So coordinate geometry can be seen as that which marries algebra and Euclidean geometry together. For example, we can represent a straight line, as y equals mx plus c, and the circle can be written as x squared plus y squared equals r squared, all thanks to René Descartes. And that is why we have the Cartesian coordinate system, right? Where we have x and y axis. So the importance of coordinate geometry, it's created a bridge between algebra and geometry. So you can say that coordinate geometry is the marriage between algebra and geometry, enabling powerful problem-solving techniques. It is widely used in physics, engineering, computer graphics, navigation, robotics, architecture, and data visualization, right? It provides the foundation for advanced fields such as calculus, linear algebra, and vector analysis. So that is the short history and importance of coordinate geometry. So, since this whole idea came from René Descartes, that is why we talk about the Cartesian plane. The Cartesian plane is a two-dimensional surface defined by two perpendicular lines. All right, you have the x-axis, the horizontal line, and you have the y-axis, the vertical line. Of course, in easy terms, we can actually visualize this. Okay. So imagine if I open this, for instance. So the Cartesian coordinate simply talks about the popular x and y axis we know. So where this is, this is the x-axis, and this is the y-axis, and this is the origin. So that's basically the concept of the Cartesian coordinate system, like that. Okay, so we have the x-axis, the horizontal line, the y-axis, the vertical line. Their intersection is called the origin 0, 0. Of course, as you can see here, so where the horizontal and vertical lines meet, that is the origin. This point where they meet, that is the origin. Okay, and then we have other concepts. So the intersection is called the origin 0, 0. Together, the axes divide the plane into 4 quadrants. Okay, we have quadrant 1, both x and y are positive. Quadrant 2, x is negative, y is positive. Quadrant 3, both x and y are negative. And quadrant 4, x is positive and y is negative. So talking about this quadrant now, we are simply talking about a situation like this, where this is quadrant 1. Quadrant 1, you have x positive, y positive. And this is quadrant 2, where x is negative and y is positive. And we have quadrant 4 down here. So quadrant 4, in this place, x is negative, y is also negative. So this is negative x, negative y. Up here, this is positive x, positive y. And here, you have negative x, positive y. And when you come here, you have positive x. Oh, why did I write one here? Not necessary. So you have negative x-axis, and then you have positive, you have positive x-axis. Okay, you have positive, okay, I didn't have to do that. So positive x-axis and negative y-axis. So this is the positive x-axis and the negative y-axis. So these are the four quadrants. This is quadrant 3 now, and this is quadrant 4. Okay, so these are the four quadrants we have as far as this is concerned, like that. Okay, these are the four quadrants. And having said that, we can then see that each point on the plane is identified by an ordered pair, x, y, called its coordinates. So the first number is the x-abscissa, the horizontal position, and the second number is the ordinate, which is the vertical position. So if we come back here again, okay, and we have this. So every point, so if you pick any random point, this can be, so you can trace it down to the x-axis. Whatever value is, that's the x value, and whatever this is, that is the y value. So you have the abscissa for x and you have the ordinate for y. So you have this ordered pair like this. So if you take any random place here now, okay, this is a point. So you trace it here, you get a particular value of x. You trace it here, you get a particular value of y. So this is x, this is y. Of course, in that case, x is negative. So you have x, comma, y, like that. So that is the system like that. And with that in place, we also understand, we can then plot. So if you, with the abscissa and the ordinates, you can then plot points with examples, right? So to plot a point xy now, you need to start at the origin 0, 0, like that, and then move horizontally according to the value of x. So you move right if x is greater than 0, you move left if x is less than 0. So then you move vertically according to the value of y. So you move up if y is greater than 0, and you move down if y is less than 0, and then you mark the point. Okay, so what you simply mean here is this, that if you need to plot a point, so you have this is the origin here now, this is the x-axis, and this is the y-axis. So starting from the origin, so if you want to locate a point, all right, let's say you want to locate point, minus 2, comma 3. That means x is negative, right? So from the origin, x is positive in this direction, it is negative in this direction. So it means minus 2 is going to, let's assume minus 2 is somewhere around here, okay? And for 3, that's y. It means y is positive. So talking about y now, so y is negative in this direction. You move downwards for y. You move for negative y. You move upwards for positive y. So since this one is 3 now, so let's imagine that the point is around here. So if you take this up, if you mark this up and take this horizontally, so that's not looking accurate, but I mean, just get the gist. So if you mark this up and you have this, so where they now meet, this is point minus 2, comma 3. So that's how you plot points in this situation. Okay. With that in place, we can have some examples. So you have 3, comma 2. So move 3 to, oh, so it means you for 3, comma 2, right? Move 3 units right because that's x, and then move 2 units up. So for 3, comma 2, like that, you have 3, comma 2. Okay, so here now, okay, let me plot all the points on one place. So you have x, you have y. So for 3, comma 2, like that, 3, comma 2. So, okay, let me even label. Okay, I guess I want to do a better, a better job of labeling so we can have a bit of clarity as much as we can. Okay, so let's, we want to do 3, comma 2, right? Let me redraw this. So let me follow this line. It's not perfect, but let's just use that. So this is the origin for sure. And then we have, let's say this is 2, 4, 6, 8. So 3, comma 2 now is we need 3, comma 2. So this also 2, 4, 6, 8. So I mean 3, comma 2 means both x and y are positive. So 3 is somewhere around here. Okay, let's start with this. So 3 is somewhere around here, okay? And 2, this is 2. So if you go this and you go this is 3, comma 2. So 3 steps to the right and 2 steps up. That's 3, comma 2. The next thing we need to point out is minus 4, comma 5. Minus 4, comma 5. So again, you have, this is minus 2, minus 4, minus 6, minus 8, okay? Of course, let's do this too. Minus 2, minus 4, minus 6, and minus 8. So minus 4, comma 5 would be this. So let's do this. Minus 4. So you move 4 steps to the left, and then comma 5, you move 5 steps up. So this is 5. So if you bring this and bring this, so this is 4, comma 5. Okay? Then we can do another one is minus 2, minus 3. So move 2 steps to the left, this is minus 2. Then move 3 steps down, that's minus 3 here. So this. So you have minus 2, comma, minus 3. Lastly, you have 6, comma, minus 1. So that means that you move, so you 6, comma, minus 1. So you move 6 steps to the right, that is 6 here. Then 1 step downwards, that's minus 1 here. So if you bring this and this, so this is 6, comma, minus 1. That is how to plot points like that. Okay? All right. So these are the examples now. So move 6 units to the right, then 1 unit to the 1 unit down. Now, interestingly, we can use Desmos. So I used Desmos a couple of times for, especially if you need to plot graphs and everything. So you just come here and type Desmos, and then you need the beautiful free math, right? And you want to do you need the graphing. So in this case now, the first thing we need is 3, comma 2. Just come here and do 3, comma 2. Okay, that doesn't work. So put it in bracket. 3, comma 2. Okay, so you see, it automatically appears there. 3, comma 2. So you can label it if you want to call it pointer or anything. So we can do that. But for now, maybe later we can do that. Then you need minus 4, comma 5. So minus 4, comma 5. Minus 4, comma 5. So you can see that's blue here. So red is 3, comma 2, then minus 4, comma 5. The next thing is minus 2, minus 3. So minus 2, comma, minus 3. Okay, so you see that's the green one here. Then lastly, we have 6, comma, minus 1. Okay, that is this right here. So you have all these things happening like that. Okay, so you can use Desmos also for this. Now, having done that, now, of course, these things you have done, we can also use Python. So, I mean, you can do a rough plot, okay? So here now we define the example point, 3, comma 2 as 3, 2, minus 4, comma 5, minus 2, comma minus 3, 6, comma minus 1. Then you create a figure and axis. So you have figure, axis, plot, sub point. Then for label, so for each of the labels now, X, comma Y in point items. So you can see you have the points right here now. So in point items now, so you plot X against Y and put this dot here. So you label that, and then you keep doing that, and then set the limits and add grid lines. Okay. So because the biggest number to the right is 6, the biggest number up. So based on that, if we do minus 7, 7, none of the values is up to 7. So we can just set a limit of minus 7, 7 around so that we know every point we need falls within that line. Then we add horizontal and vertical lines for the axis, okay, at the origin 0, 0. So I will give them color black with line with 0.5. Then we can add labels, x-axis, y-axis, and then plotting points on the Cartesian. That's the topic. So if you run this now, that just generates it. So I've done it manually, plotting the points on like the way I showed you, using, plotting the points right on my own. And then here now, I've also shown you how to do it on Desmos. Now this is how to do it with Python like this. So, of course, this is just an introduction. You can begin to now try this. You can say, identify the quadrant in which 7 minus 5 lies. Of course, X is positive, Y is negative. That will be X is positive, Y is negative. That should be the fourth quadrant, right? That will be the fourth quadrant. So if this is the origin, so if x is positive, this here, y is negative. So that would be this fourth quadrant in that case. Then plot the point -3, 4 on the Cartesian plane and state its quadrant. So -3, 4, and we call that point Q. Okay, so you can just come here. So I can remove all this. Okay, I remove all of this. So that's point -3, 4, and we want to call it Q. So -3, 4, and that's supposed to be point Q. So you need a label now. So you now say, so you label it Q, then -3, 4. You can label it like that, and you have this right here, like this. Okay. Now, so you can try all the other ones. Write the coordinate. Of course, what coordinate is that? That's the second coordinate. X is negative, Y is positive. That's second quadrant, sorry. Second quadrant. So you can try all these other ones out and see what happens, right? So with this, I come to the end of this introductory video on coordinate geometry. Let me know how helpful this is for you. And if there's something you'd like me to try out as far as this topic is concerned, feel very free to let me know. Don't forget to try these practice questions. They will really help you to learn fast. And if you have access to a phone, you can open Desmos on a phone. You can open it on a computer. So Desmos can be your companion in this whole process. Okay. So if you have subscribed already, I thank you so much. If you haven't, of course, you don't want to keep missing out on these great things. So why not go ahead right now and subscribe? Then don't forget to hit the notification bell so you can always get alerted each time a new video is released. Beyond that, all right, don't forget to uh so after subscribing, right, you can take it a step further. You can click on join to become a member of the channel, and that gives you some extra special privileges. Okay, so you want to explore that option. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.